Last class we have considered regarding if statement as well as case statement. In this class, let us discuss regarding while loop, for loop as well as repeat and forever loop. So in case of while loop, as I mentioned yesterday, we need to check a particular condition. If the condition satisfies, then it will going to enter the loop. And if the condition does not satisfies, then it will not enter the loop. And here we cannot exactly sometimes we can predict that how many times this loop will going to run, and sometimes we cannot predict, because when the condition will become false, then immediately it will come out of the loop, otherwise it will be in the same loop as long as the condition is true. So that is why here we are going to check the expression, and if the expression is true, then only it will execute. And if there are more than one expressions, or if there are more than one statement, it should be within the keyword begin and end, so that all those statements will be executed when there are more statements. Now, in this example, we have considered a counter. When we are considering a counter, we need to increment the count and it has to be displayed. So, what we are doing is we are incrementing the value from 0 to 127, and whenever it exceeds 127, we should stop displaying. So, for displaying, we have written the corresponding code here. Initially the count is set to 0, then we will going to check whether count is less than 128. Since the value of count is 0, this condition is true, and then it enters the loop and it will going to display count equals %d, that is the decimal value present in the count will be displayed. And afterwards we are incrementing the count. Remember here, if we do not increment, what happens? If we indicate only one statement, display count is equal count, in that case count value will not change and count value will remain 0, and this will enter infinite loop until unless the count value has to change. It will not come out of the loop. So that is why while mentioning the condition, we should be very careful what condition we are mentioning. So based on that, whether it has to become true or false, it will going to check. Okay, so that is why in order to come out of this loop, I need to increment the count. Now the value of count is equal to 1. Once again this condition is true, it will execute this. Like this count will going to increment up to 128. When it is equal to 127, then also this condition is true, it will execute. But when it reaches 128, this condition will become false. When the condition is false, it has to come out of the loop. So that is why here this statement decides when it has to come out of the loop. Instead of giving count is equal to count plus 1, if I mention count is equal to count plus 2, so there what happens? Previously, when count is equal to count plus 1, we used to get the values from 0, 1, 2, like this. Up to 127, it used to display. Okay. Now, if I mention count is equal to count plus 2, it will count only even numbers. That is 0, 2, 4, like this. It will count only even numbers. And as soon as it becomes equal to 128, it will come out. So, up to 126, we will going to get the count. And here, how many times the loop has been executed? It has been executed 128 number of times. But here, how many times it will execute? I'm incrementing by 2, right? So it has to execute only 64 times. So after 64 times, the value of count will be incremented to 128. So it will come out of the loop. So like this, we cannot predict properly exactly how many times it will going to run. It depends upon this statement. Instead of 2, if I mention 3, then compared to 64 number of times, before that only it will come out of the loop. Okay, so like this we will going to consider the corresponding conditions in while loop. While placing condition in while loop, we should be very careful that it should not enter any infinite loop. That care we have to take. Okay, that is one of the main importance in while loop. And this is another example. So in this example what we are doing is we are checking when we are going to get the first bit which has been set to 1. So if this is the corresponding number of bits present in this register, here I am defining continue is equal to true. I don't know at which particular position I may get 1. In this example, I'll get 1 at the position 13 because this is 0 and here I'm going to consider this as 15. So at the 13th position, I'm getting 1. I have defined this. Suppose if we don't know the value of flag, when we are reading value of flag from some other input, in that case, we have to identify which particular bit has been set, means which is the first bit that has been set. So that is why here we are initializing. It has to start checking from 0th position, so I is initialized to 0, and then we will going to set a flag, that is continue is equal to true. Okay, and here I have taken tick true. So tick indicates that I have defined what is true. True is nothing but one tick binary 1, and I am defining false as one tick binary 0. So that is why here we are going to mention the condition continue is equal to true. In that case we will going to check the total number of bits is 16. Either the count should reach 16 or the continue should be true. Till then it will going to execute. When the count reaches 16, it will come out of the loop, or when the continue become false, it will come out of the loop. To enter the loop, these two conditions must satisfy because I have used AND operation. When I use AND operation, this side, that is the left hand side of the logical AND should be true, as well as right hand side of the logical AND should be true. When both are true, then only it will enter the while loop, and then it will going to check whether the ith bit of the flag is equal to 1. If it is equal to 1, then execute. Encounter a true bit at element number, the corresponding position in I. And after identifying the first bit which has been set from the LSB position, then we should make continue equals tick false. When continue is equal to false, then it will check the condition once again. If both the conditions are true, it has to enter. Since the continue become false, so this condition will become false. As soon as this condition become false, it will come out of the loop. It will not going to execute this once again. So this is how we can able to consider while loop. So that is why I told that we cannot predict exactly how many times it will going to run. It depends when the condition will become false. If the condition never become, if the condition is always true, then it enters infinitely. Okay. And next what we are having is for loop. This is more structured way of representing while loop. So why it is called as more structured way? And because here I am determining how many times it has to run. Means I am specifying the number of times that it has to run along with the condition, the whether the condition is true or not. So that is the reason I am going to tell this as more structured way of representing the while loop. So what for loop consists of? It consists of three parts. One is initial condition of the loop variable, and then I'm going to mention when it has to terminate, that is the final condition of the loop variable. Between this initial and final condition, with what steps it has to change, that is mentioned in for loop. So that is why here we can observe in this for loop, I'm taking an example like for count equals 0, count less than 128, count is equal to count plus 1. Same counter example I have taken to illustrate that we can replace for loop, sorry, while loop using for loop also. So in this, first only I am mentioning initial value of count is 0, and if the count is less than 128, till then it has to execute. As soon as it reaches this terminating condition, it should come out of the loop. And then also I'm mentioning how the count has to change its value, whether it has to increment by 1 or it has to increment by 2, or even I can perform down counting, that is count is equal to count minus 1. When I perform down counting, what happens? I need to set initial value for higher count, and then I have to check the condition. Here I have set the initial value for lower count, that is why I am incrementing. And if I want to decrement, then I need to set count for higher value, and then I have to perform decrement operation. So like this it will going to display. And here we can exactly tell that when it can come out of the loop, because we are mentioning the terminal condition, and also we are mentioning how the count variable has to change. Okay, in case of while loop, if we skip to mention how the condition of loop variable has to change, in that case it may enter infinite loop. Okay, even though if we miss, it will not going to show any error, but in case of for loop, it will going to show error when we miss this part. Because for loop syntax, according to the syntax of for loop, all the three states has to be mentioned, that is nothing but initial condition, final condition, and then the loop count, in which particular steps the loop has to proceed, loop variable. So if we do not mention all the three things, we'll get syntax error. So obviously we will going to mention. According to this, it will come out of the loop after a particular number of iterations. So that is why it is called as more structured way of writing loop compared to the while loop. Okay, and this is one more example what we are considering. Here we have defined the maximum number of states as 32, and now we have to check, or we have to set all even number of states to 0 and odd number of states to 1. So how to set this? Since there are 32 bits, instead of writing 32 times, that is state state of 0 equals 0, state of 1 equals 1, state of 2 equals 0, state of 3 equals 1, like this I need to write 32 times. Okay, otherwise by using this for loop, I can able to write, the code length can be reduced. It will also do the same operation, means the loop will be repeated that many times I want to write. So here you can observe that I have initialized I is equal to 0. 0 is a even number. So now up to I less than 32, it has to execute, and I has to increment by 2. So what we are going to get? 0, 2, 4, 6, like this even numbers we are going to get. So now I'll mention state of I is equal to 0. So as a result, for all the even number of bits, the value 0 will be placed. And for odd number of bits, for the same while loop, I'll just repeat the same for loop, not while loop. I'll repeat the same for loop, but with the initial value equal to 1. Okay, instead of 0, I'm initializing it to 1. Since 1 is a odd number, 1 plus 2, the next odd number is 3, and the next odd number is 5. So like this, I'll be getting only odd numbers between the value 0 to 32. And now for those odd positioned bits, value 1 will be assigned. This is how we are going to consider for loop, how we can able to initialize array, or how we can able to initialize memory. All these things, for all these things we can use for loop. Okay, and the difference between for loop and while loop is, while loop is just like more general purpose, means specifically we are not mentioning exactly how many times it has to run, when it has to come out of the loop, all these things, but simply we are mentioning only one condition. If this condition is true, execute, else do not execute. But for loop, in a structured way, we are representing how many times it has to run and when it has to come out of the loop. Okay, that is the main difference between for loop and while loop. And next, we are having one more loop called as repeat loop. As I told in the previous class, repeat loop means it will going to take only count as the input. How many number of times it has to run. It won't check any other condition. In the previous examples like for loop as well as in the while loop, we have taken the condition like uh, if the value of count is less than 128, then while loop has to execute. Such type of conditions repeat loop will not going to check. It will just check the number of counts, and then it will going to run for a fixed number of time. Okay, so here that is why it is mentioned a repeat construct cannot be used to loop as a general logical expression. Only in such case while loop we have to use, based on the condition it has to enter. But when I use repeat, it has to execute for a fixed number of iterations. Okay, and that number I can directly represent here, or by using some parameter, or by using some variable I can able to represent. So here we can see the example. Initially the count is 0 and I have mentioned repeat 128. So what this will going to do? Begin, and in this repeat loop it will going to display this message 128 number of times and it will come out. And after every iteration count is incremented. Suppose if I miss this particular statement, okay, what happens? It will going to display count is equal to 0 128 number of times, and then it will come out of the loop. See, let us consider the difference between while loop and for loop. So when I mention while I or count less than 128, it has to enter the loop, and then I am mentioning only dollar display count equals percent d comma count. Okay, and I am not mentioning count equals count plus 1. In repeat loop also I have removed this line count equals count plus 1. Now when we execute using repeat loop, it will just going to display count is equal to 0 128 number of times it will display and come out. But what this will going to do, it will also display count is equal to 0, but it will not come out of the loop, because always as long as count is equal to 0, this particular condition count less than 128 will be true. So this will going to enter infinite loop. It will not come out, but this will come out. That is the difference between repeat loop as well as while loop. Okay. And this is another example like how we can able to use repeat loop. So in this what we are doing is we are defining the count in terms of parameter. So we have to read 8 bytes of data, or for 8 cycles of clock pulse we need to read the data. So that is why here we are defining the count in terms of parameter. And then here we are initializing, sorry, the input is data start, and every data is of 16 bit, and the input, another input is clock. Whatever the data we are going to read, it should be stored in a buffer, and that the length of the buffer is 8. So only 8 16-bit data it can store. So that is why I am mentioning the parameter as 8. And in the always statement, during every positive edge of the clock, it will going to check whether the data start is 1. If the data start is set true, then it has to initialize I is equal to 0, and then it will going to repeat this for 8 number of times. Why I am initializing I is equal to 0 means I need to consider 8 different locations. So in order to consider different location, I am using a variable I. So in this it will going to take buffer of 0, and it will going to execute. And after executing this, what it will do, it will increment I, and then the count is not yet equal to 8. So once again it will come over here. So it will take buffer of 1 will be loaded with the data, and once again it repeats. So like this it will continuously read 8 bytes of data, and it will come out of the loop. This is how we can consider, means where the application of repeat loop is present. Means when we know for a fixed number of time a particular work has to be done, there we can use the repeat loop. Okay. And next what we are having is forever loop. As I told, it will never come out of the loop. So when such particular conditions are there, we will going to use forever loop. Continuously it will be keep on executing. Then how to terminate that? In order to terminate that, we have to use $finish or $stop. So by using this, we can able to stop the loop. Otherwise, only that particular loop will be keep on running. Here, one of the example is clock generation. If you want to generate a clock, first in the initial block, I'll just initialize clock is equal to 0, and then I'll going to use forever loop. So in this forever loop, what it will do, for every 10 time units of delay, the clock will be negated. So like this, it will keep on generating the clock. In order to terminate this forever loop, where we have to mention $finish, we cannot mention $finish inside the forever loop. We have to mention $finish in another initial statement. In the another initial statement, why we have to mention? Because both the initial statements will be executing at a time. So when both the initial statements are executing at a time, and after a large delay, I am using $finish means it will stop the execution of the entire stimulus. So it will stop generating the clock. Okay, that is how we are going to consider in case of forever loop. Okay, so this is regarding the different types of loops. Next, what we are having is sequential blocks, means different types of blocks. So one is sequential and the another one is parallel. In case of sequential block, what happens is every statement will be executed one after the another. It is similar to blocking statement, writing program using blocking statement. Okay, so that is why here the order of the statement is important. If we do not follow the order properly, then until the execution of current statement, the remaining statements will not execute. So that is why we have to follow the order, and in this sequential block, that is one of the main requirement. Okay, and if delay is specified, then until the completion of delay, it will not go for the next statement, so it will be keep on blocking the execution of further statements. Okay, and this is one of the example of sequential block. Here we can observe that we have written this sequential block without delay. So when the execution of initial block begins, in that case 0 will be assigned to x, 1 will be assigned to y, and z will be assigned with the value 0 1. Why we are going to get the value 0 1? Because the msb bit here is x and lsb is y, and for w the value is equal to 1 0, because the msb bit here is y and the lsb is x. So we are going to get this value. But when we are using with delay, then what happens? Here we are going to get this value without delay. Okay, and here with delay we are considering. So first it will assign x equals 0 at time 0, and it will assign y equals 1 at time 5 time units. And then after assigning this, then another 10 time units it has to wait. So from the beginning, totally it is 15 time units. Here 5 time units, and after this another 10 time units, and then it will assign the value 0 1. Okay, and after executing this, it has to wait for another 20 time units. So already 15 time units is over. From that 15 time units, another 20, so totally 35 time units it will going to take to execute this block if I mention a delay in case of sequential block, because here only blocking statements are used, so they will going to execute one after the other. And if you want to execute any statements parallelly inside the always or initial block, then we are going to consider parallel block. And the keyword for parallel block is fork and join. When we are going to consider the keyword begin and end, it indicates sequential execution one after the another. But when we consider the keyword fork and join, it indicates the parallel execution. Why the name fork and join is given? Because here all the statements will belong to the same block, but they will going to start executing from 0th time unit parallelly. Okay, it looks like a fork attached to a particular stick. Means they all these statements belong to the block 1 only. Okay, but they start executing from 0th time unit as a reference. So as a result, inside this block they will execute parallelly, but they belong to a block. That is why the name fork and join is considered. Okay, and here the order is not important, because all the statements are executing at a time parallelly. So the order of the statement is not important, but in the sequential block order is important. And if a delay is specified, now let us observe in the example. Here we can consider this particular example. The same example I have taken. I have replaced begin and end with fork and join. Okay. So now this statement will execute without delay, and this statement it will take 5 time units of delay, and while executing this statement it will take only 10 time units. Previously, in case of sequential block, after this was executed. So that is why it took 15 time units of delay. But here, since all those four are parallel, it will take only 10 time units of delay. Okay. While executing this, 10 time, and while executing this it will going to take 20 time units. So that is why totally to complete this block it will going to take 20 time units. Previously if I use sequential block it will take 35 time units, because the delay will be accumulated where by the time it reaches the last statement. But here the delay is not accumulated. Okay, that is the difference between sequential and parallel blocks. And here also, when we consider this without delay, so here what happens is implicit race condition we are going to consider. So why implicit race condition means, see, while executing this, all this has to execute parallelly, but the simulator, as we know, it will execute one instruction at a time. It may execute this first or it may execute this first. Okay, suppose if I consider if it is executing third statement first, then while executing the third statement, value of x is not yet updated, so it will take the previous value. And even while executing the third statement, value of y is not yet updated, so it will take the previous value, and then previous values will be assigned. So that is why we are going to call it as it can have implicit race condition if we do not mention delay. But here I have mentioned a delay. By the time of executing z, the value of y and x were updated. So that is why I used to get correct output. Even though they execute parallelly, I used to get correct output. But here I may not get correct output. Why I cannot able to get correct output? Because all these will execute parallelly, and as they are inside the initial block, they will execute only once. If they are concurrent statement, then as soon as the input changes, immediately the corresponding statement will execute. But here they are present inside the initial block, and inside the initial block every statement will be executed only once. So as a result we may not get the correct output due to this implicit race condition. Okay, so that is the example I have explained here. And in order to avoid this implicit race condition, usually we are not going to use fork and join. The blocking statement only we are going to use, because we don't know which simulator will going to select which particular statement first and which particular statement next. So that is the reason we are not going to use fork and join much compared to this. Okay. And the next one what we are having is the special features of the blocks. So the special features of the blocks means, till now we have considered only one block at a time, but here we can see that one block can be nested inside the other block. So it can be nested inside the other block means, here we can observe inside the initial we are having a sequential block begin and end. Within this sequential block we are having a parallel block, means only these two statements are executed parallelly but not these statements. So in this case how we are going to get result? So x will be updated with 0 delay. After executing this block will be considered, but inside this block these two will execute parallel. Okay, remember one thing. So here if I mention ash 10 and then if I write x is equal to 0, so what happens is up to 10 time units this statement will not execute. Hence it will block the execution of these two statements. Fork and join is considered as one block, and this hash 20 w equals x, and so this is concatenation operation. So hash 20 w equals y concatenated x will going to execute after 20 time units. These two are treated as separate statements. Okay, but they are present inside the sequential block. So first at 10 time units the value of x will be updated, and then this fork and join will take 10th time unit as the starting time, and from there it will take 5 time units to change the value of y, and it will going to take another 10 time units to change the value of z. Okay, so from the 10th time unit these two will start executing. So as a result we will going to get this output at 15 time units, and here we are going to get this output at 10 plus 10, 20th time unit. Okay, that is what it happens, because first sequential statement is there and afterwards parallel block is there, and after the complete execution of this statement will execute. So how, when this particular statement will execute, after the 20 time units it will come out of the parallel block, and then from then it has to take another 20. So at 40 time units we are going to get the output w equals y comma z. Okay, this is how we are going to consider the nesting of block. Inside the parallel block we can have sequential block, and inside the sequential block we can have parallel block. Usually we are not going to mix, but that is also allowed. Okay, and the last type of special feature what we are having is named blocks. Means we can give name for a particular block. So why we have to give name for a particular block means, see, when we are writing a large program, in that program if there are so many blocks, sequential blocks and parallel blocks, it will be difficult to remember. Instead of remembering as it is, if we give name for every block, then it will be easy to understand. Like for example, when we are writing gate level modeling, for every gate we are giving instance name, isn't it? So that indicates that gate number 1, gate number 2, gate number 3, like this we are going to refer, so that we can easily understand. Instead of that, if I mention AND gate, AND gate, AND gate, so there are n number of AND gates. How I will come to know which AND gate is performing which operation? Means which inputs has been given for which AND gate. It will be confusing, isn't it? So in such case, we are giving numbering for our convenience. In the same way, for user convenience or for programmer convenience, the names can be given for a block. And whenever we want, we can enable the block, and whenever we want, we can disable the block. Okay, that is how we can have. So first, let us see how we can give name. So when we consider any block, it starts with begin. If it is a sequential block, if it is a parallel block, it will start with fork keyword. So in front of this keyword, we will write colon, and then we will give name of the block. And suppose if we want to disable, so when we are willing to disable a block, see, while writing a large program, we want to check functionality of some small program, some small blocks. So in such case, after checking the functionality, instead of deleting the particular program, so that particular testing program, we can able to disable the block, because when I delete, what happens? I need to alter the program, but I do not want to alter the program. I just want to disable after testing. So when once the test results are okay, then the code written for the test can be disabled. So for that particular block, which is testing the part of the design can be given a name and that name can be disabled. So let us consider an example how we can able to disable. In this example, we can see that whenever it identifies the same example I have taken, that is to check in which particular bit the logical value 1 is present. So in this, what we are going to do, we will going to check whether the value of I is less than or equal to 16. If the value of I is less than 16, then it enters the while loop, and then it will going to check whether the particular bit is 1. Here, since I has been initialized to 0, when I is equal to 0, 0th bit will be tested. Since the 0th bit is 0, it won't execute this. It will once again increment this and it will enter the while loop. So like this, it will keep on executing when it reaches the position 13. In that case, the flag of I will be equal to 1. So now it will going to display. It has encountered a true bit. After encountering a true bit, then what it will do? It will just disable the block. By using the name, I can able to disable. So this entire block will be disabled. So once again, this will not going to execute. So I need not necessary to delete the program. I can directly disable by giving the block name. So this is regarding the corresponding special features of blocks.